Hello everyone, I hope you all are doing well. This side Priya Bhatia. And in this specific video, we will start our next new module, which is all about model evaluation techniques. Although we have covered up a lot in our previous sections of the machine learning course regarding this model evaluation part, starting from the linear regression discussion where we have talked about MSE, MAE, we have talked about R square, adjusted R square, we have talked about a lot in confusion metrics, and there are a lot many stuffs which we already have covered up. Still, there are a few things which I feel you can say it's a part of a miscellaneous ML portion which needs to be covered up and for which everyone should be having an awareness. And at the end of the day, whenever you feel like that, okay, my model is somewhat overfitted, or I need to do more advancement on my model part in terms of evaluation, you can apply this kind of a knowledge as well. So in this specific module, as a very first part of the section, we will talk about cross validation. It's one of the most important technique, and today we will discuss what are the different types of cross validation techniques that we have. I will try to showcase you the implementation for the same as well. But before jumping towards the implementation, as you all know, our way should be to first of all understand the internal intuition behind this part, why it is required, what's the need for that, and then maybe we can move ahead with respect to the implementation part step by step. So now, before deep diving into that, how basically this cross validation techniques are, what are the types of that, how can we implement that? Let's try to focus on what is the need of this cross validation technique, how it is beneficial and why we are discussing this thing. One interesting thing, if you will observe from the starting of our machine learning course, where we have learned about our very first model of linear regression, if you remember, uh, I always said that what we want at the end of the day is a generalized model. For example, if let's say we are talking about a linear regression, what we were looking in that case is the best fit line where y is equals to mx plus c. And if you remember at that point of time, I told you that what we want at the end of the day is the optimal value of m and c, which generalizes well for all the datasets that we have. Means, in other words, the error will be minimum. If you remember, that's the statement which I kept on repeating on all other models as well. So what we want at the end of the day in machine learning models is basically that our model will generalize well on different kinds of data sets that we have. Uh, it's not only on training set, but also on testing set or unseen data as well, right? So that's the whole target. So this cross validation technique basically helps my model to do a better generalization of a model. So it basically helps to do the generalization of the model. So basically, be it any model that you have, it will generalize well, means on unseen data, it will be able to perform well. Second interesting thing which you will be able to observe is that it will be able to reduce the overfitting. So wherever you feel that there is a good, I would say, accuracy in terms of the training set, but as soon as my model went to the testing set, it performs really bad. That's something which we call as overfitting, right? So that's also correlated with the generalization itself. But in other words, if someone will ask you, you can also talk about this specific point, that at any point of time, if I want to reduce the overfitting, meaning that at any point of time, I want the training accuracy plus testing accuracy also to be very, very good, means low bias and low variance, that's the time. So basically what we want here is the low variance, right? That's something which we want. So let's try to understand now, and let's try to deep dive into this cross validation part. There are different types of techniques that we have, but before jumping towards that part, always remember that cross validation technique will only be applicable on the validation set. So till so far, whatever projects we have done, I have talked about usually in maximum instances that let's say we will be having a data set which contains, let's suppose, 1,000 records, right? Let's suppose we will be having a data set in which we will be having, let's say, 1,000 records. We usually have a habit to split this data into training and testing, right? So we say that, let's say train set will go 80%, means almost 800 records will be available here. And in the testing set, let's say we will be having 20% of the records. So in this case, almost 200 records belongs to the test set. That's usually which we do, right? In the training and the testing part per se. Now, what we are trying to do here is that, let's do one thing. We will further split this training set into two components. One is the further train set. Another one is the validation set. And whatever be the cross-validation techniques we're discussing today will be applicable on this specific set. So whatever be the cross-validation techniques we will discuss today, all those techniques will be applicable over here only. Okay? All those techniques will be applicable over this specific part only. Always remember that. We will not touch upon the test set. It's something which is unseen data that we have, and we will never ever touch upon that part. This is unseen data, and we will not ever look for this specific data. It's just that at the time of final evaluation, that whatever we will do at the end of the day, at that point of time only I'll touch upon this test data. Okay. So let's try to focus on this specific scenario where we will be having train set and validation set available. So how the things will flow, that's the main thing which we have to discuss now. So let me try to fetch up one image here with respect to the cross-validation set, and that picture will really help you to understand in a better manner what I'm trying to convey here. I hope that this picture is pretty much visible to everyone in the screen. Now let's try to deep dive into cross-validation techniques. There are multiple techniques, by the way, we could have. The very first basic technique which you must have heard of is leave one out cross-validation. I'm just writing CV here. Leave one out cross-validation. What it usually says is that, let's say we will be having, here, don't consider it as a fold. For now, let's consider that in the training set, which we are further splitting into training and validation. Here, this validation and test, they're referring it as the same, so don't get confused. With this, I'm just referring the validation set only, okay? So what I'm trying to convey here is that, let's suppose that we will be having only 5 records. Let's assume that we will just have 5 records available in the total train set. So in the leave one out cross-validation, what we will do is, at every iteration, we will first of all pick the first one as the validation set. Then we will pick the second one as the validation set. Then we will pick the third one as the validation set. And in every random part of the validation set that we are doing here, step by step, we are trying to do applying whatever model you are applying. Maybe if you are it's a classification problem and you are applying random forest, you will keep on applying that for all the kind of permutations and combinations that we have. But the simple thing which you are doing here is that at every iteration, you will take one, you can say, validation set out. That is one single sample out. It's just a single sample. Let's assume that we will just have 5 records in a train plus validation set. You are taking only single set as a part of a validation, and that also you will keep on changing at every iteration. Because you have only 5 records, you will do 5 iterations, changing the value of the validation set, and finally getting the performance of the model. And what you will do at the end of the day is just trying to average down all those performances to get the final result. That's a part of a leave one out cross-validation, where we just have a number of samples and we're just putting one out of that. That's why it's called as leave one out. In the second part of the, you can say, cross-validation technique, another technique that we have is hold out cross-validation, where we will not take a single validation set, because what is happening is, in real world instances, we don't have only 5 records. We have 5 million records. We have lot many data points. So is it feasible to have that 5 million iterations at a time? So you can assume that how much training time will it consume if we will do like that. So that is where the performance wise, this is not that much a good idea. That is where the introduction of this holdout cross-validation came into picture. By the way, you can ask me a question that, Priya, why we are doing so? Why we are taking a validation set, keep on changing it every instances in this pattern. The only reason is what we want is to reduction of the overfitting. What we want is that our model will generalize well, means it will give a perfect results for the unseen data points that we have in the test set that we will be having here, right? That's the core idea. Generalization is the core idea because of which we are doing this specific task, right? What we usually do if we just directly split our data into training and testing, we are not changing the random samples that we have as a test part, right? We're just training it in one go and checking it out. But if we'll do this kind of iterations, what will happen is generalization will happen in a more appropriate manner, right, of the model. What is happening in holdout? So holdout says that instead of taking only single sample, why not take a proportion of that? Maybe you will take 20% as a part of a validation set, just like we do a split of training and testing, right? So you will take as a validation set, and maybe 80% of the records you will consider it as a maybe final train set that you have. And what you will do, you will repeat the same step again. Means first 20%, then second 20%, the third 20%. Means now you can assume the same chart, but here you're taking first 20% of the records, here you're taking next 20% of the records, here you are taking next 20% of the records, here you're taking next 20% of the records, and here you're taking next 20% of the records. Means in this case also our validation set keep on changing. It's not that it is fixed. That's the main idea. That's the main goal. That's where generalization is happening. But here, instead of taking one single sample, we are taking a proportion of that let's assume 20%. So now what will happen if, let's say, you will be having 800 records available. So in that, you are taking 20% as a holdout, which you are taking here, and 80% will remain out of these 800 records as a training set. And again, you will do the same task. You will apply random forest classifier to do the iterations. If it's a regression problem, you will apply random forest regressor. It will generate some results. You will try to evaluate that and get the average performance of the same. In the next iteration, which is a very widely used technique in the real world instances, is k-fold cross-validation, which is more better as comparable to above ones as well. It says that, for example, we will be having number of records as 1000. So what we will do is we will try to make the folds here. For example, you are saying k is equals to, let's say, 10. That I want to curate 10 folds. So what will happen is that in every fold, what you are doing is you are doing 1000 divided by 10, which is equals to 100. So what you are doing, you are saying that I will try to curate 100 folds. I will try to curate 100 folds, and in every fold, I will have 10 folds, and in every fold, I will be having 100 number of records. I hope it makes sense. For example, in this particular diagram is of k-fold, cross-validation technique, which is very, very widely used. So what will happen is I will try to curate fold 1. I will try to curate till fold 10 with respect to the example which I have given you. And in every fold, I will be having 100 records. So 100 into 10 is 1000, composing of train plus validation. Now what will happen, at every iteration, we will keep on changing that fold value. For example, in this specific case, fold 1 will become our validation set. In the second iteration, fold 2 will become our validation set. In third iteration, fold 3 till fold 10, we will keep on changing that validation set fold, right? That's the another idea. If you will be able to observe, in every particular technique that we have, the task or internal intuition is same. We will keep on changing the validation set that we have. In leave one out, just single record. In hold out, we have some percentage. In k-fold, it's a more better version, which is basically having lesser iterations. We'll be able to give the result faster. And on the same part, it will be able to reduce the overfitting as well. That is why in the real world instances, this is one of the, I would say, most widely used technique as well. This is one of the most widely used technique as well, right? Very, very widely used technique. And at the very end, we have something called as stratified k-fold cross-validation technique as well. Specifically, if let's say you want at any point of time, let's suppose you're dealing with a classification problem, and at every point of time, you want to make sure that there will be a equal class proportion there will be a equal class proportion. What is the meaning of that? It will basically take care of the unbalanced or imbalanced classes if data contains. So in that case, if you want to make sure that if my data doesn't have that issue, or my cross validation automatically will be able to tackle that, so always go for certified k-fold cross validation technique. Internally, again, the intuition will remain same. It's just that it will be able to tackle that imbalanced class part and make a proportion of equal classes. For example, if you will be having 0 and 1 class available, so 0 and 1 both should have 50-50% ratio, right? So that is where we will always go for certified k-fold cross validation. So these are the techniques that we have with respect to the cross validation part. Now what I will do is I will try to showcase you the code implementation of, let's say, k-fold. With respect to other techniques, same code work is required to implement the part, right? So let me try to take up one specific code which I can showcase you. Maybe I'll take up the code of k-fold cross validation and let me try to showcase you that thing. Let me first of all fetch up the Google Colab file. So let's try to open Google Colab, and here let's open the new notebook, and what I'll do is I'll try to showcase in the session k-fold, and will give you a task where you have to implement other cross validation types which we have discussed so far. So here it's a cross validation techniques implementation. So let's try to connect this file, and here I have a code available. I'm just copying it down. So what I'm doing is I'm just taking up the open source data available in sklearn.datasets with the load_iris. And here, this is a part of a model underscore selection module. So we want a cross validation score, and what we want to use is a k-fold. If let's say you want to use stratified k-fold after some point of time, what you're supposed to do is you have to just call that particular function which you want to use. I want to implement random forest classifier. Import the numpy package. Here you can see we have just directly loaded the data. X and Y is our target and the input features that we have. Here we have a classifier available. And finally, what we are doing here is we are just directly applying this k-fold method. Now here you can see very clearly number of splits. Means here we are mentioning about the number of folds that we want, right? Which is equals to 5. So let me just open this k-fold documentation, sklearn documentation, so that we will be able to get a better understanding for the same, so that we can also see about the different parameters that we have. So here you can see cross validation is evaluating a estimated performance. It learns the parameter of a prediction function, testing it on the same data. What I want to showcase you, I just want you guys to also refer this documentation. So here this is all about the folds that we have, but what we are looking for is specifically k-fold. So that is the documentation. So here you can see number of splits. Shuffle is by default false, random set is none. So here you can see shuffle is a bool parameter, whether to shuffle the data before splitting into batches or not. So at every point of time, whether you want to shuffle data before doing that splits, or you want it to go by default, it is false, but you can make it true as well. So here you can just try to see there are limited number of parameters that we have, and number of splits is by default 5. If you want, you can take 10, 20, whatever be the record size that you have. Depending upon that, you can decide, right? After that, you can call this cross validation score, which will take CLF, which is the model value that you have, the value of X, the value of Y, and the cross validation which you have specified, which is KF. And the scoring parameter is accuracy. And once you run this specific code, you will be able to see your complete results. So you can see k-fold cross validation score is 1.9, because you know that it's 5. So random forest classifier will run internally 5 number of times with the different folds having the validation set. I hope you are now able to remember whatever points I have discussed. So every particular instance will give the sum results, which is the accuracy part. And the final result is the average of all the 5 accuracies which we will be able to get. And that's why we will be able to get the accuracy of 96% here in this specific case. One more interesting thing which I forget to tell you is that this cross validation is also specifically used for hyperparameter tuning as well. For hyperparameter tuning as well. For hyperparameter tuning as well. For example, if let's say we don't know what is the optimal parameter for any specific instance, for any specific model which we are working for. So what internally happens is that if we will apply this cross validation technique, it will take and decide that, okay, what could be the possible number of parameter which we will be able to have in this specific scenario, right? So that is also a very important part. So internally, when you're calling this grid search CV or randomized search CV, I don't know how many of you have, realized this thing. Let me just show you. By the way, grid search CV is nothing but grid search cross validation. So here you can see by default, you will be having this CV parameter which is available, and it is none, which indicates the value as 5 if I'm not wrong, right? None to use the default 5-fold cross validation. So at every point of time, always remember whenever you are doing grid search CV implementation or randomized search CV implementation, same thing is happening internally. It is using the k-fold cross validation technique itself to get it optimal parameters in a more generalized manner. So I hope that with this you will get a better understanding of why these techniques are important and how basically we can implement that. In future, if let's say you want to implement certified k-fold, you just have to change this name, right? Same thing will happen for leave one out and other techniques as well. So with this, let's end today's session. I hope you feel this session must be insightful for you all. And if you have any sort of doubts, do your own research first of all. And still, if you're facing any trouble, any doubts, any thoughts you have, please do reach out to me. I'll see you all very soon in the upcoming video. Bye-bye everyone and see ya.